It turns out that it's easier to work with polynomials that have a positive leading term. When we have a negative leading term, we can fix that by factoring out a negative greatest common factor. So as an example, let's factor out the greatest common factor from the polynomial negative 5x to the fifth plus 20x to the fourth minus 25x to the third, so that the leading term of the polynomial factor is positive. So we'll have a monomial factor, the GCF, and a polynomial factor. For the polynomial factor, we want a positive leading term. So, okay, let's look at the terms of our polynomial. We have a negative 5x to the fifth, and then we have a positive 20x to the fourth. Let's look at the factors of 20 quick, right? 20 is 2 times 10. 10 is 2 times 5. So 20 is 2 squared times 5. And then that's multiplied by x to the fourth. And we have a negative 25x to the third. 25 is 5 times 5. So negative 5 squared x to the third. Okay, for the coefficients, it looks like they all have a factor of 5. For the x's, the smallest power of x is x to the third. And because we have a negative leading coefficient here, we want to make our GCF negative. And here's why. So we take negative 5x to the fifth divided by negative 5x to the third. Negative 5 divided by negative 5 is just 1. And then we have x to the power 5 minus 3. 20x to the fourth divided by negative 5x to the third. 20 divided by negative 5 is negative 4. X to the fourth divided by x to the third is x to the 4 minus 3. And finally, negative 25 x to the third divided by negative 5 x to the third. Negative 25 divided by negative 5 is positive 5. X to the third divided by x to the third is just 1. So when we factor out our greatest common factor of negative 5x to the third, we're left with, in our first term, x to the power 2, right? 5 minus 3 is 2. In our second term, negative 4 x to the first power, right? 4 minus 3 is 1, plus positive 5. And now this factor has positive leading term. Remember, the leading term is the term of highest degree, which is the x squared in this polynomial. And the reason that we like a positive leading term is that soon we're going to want to take the polynomial factor we have left and factor it further, and that's easier when our leading term is positive. Now, sometimes we don't really have any common factors between the terms, but we still want to get rid of a negative leading term. In that case, we can just factor out the number negative 1. So we have the terms negative 3x squared, negative 7x, and 9, which is 3 times 3. So our coefficients don't have any common factors because negative 3 and negative 7 are prime. And then this term has no variables. So there are no common numeric factors. There are no common variable factors. In this case, the GCF is just 1, which is very boring to divide by. But Because we want to get a positive leading coefficient, we're going to use -1. So we'll say negative 3x squared divided by -1 is positive 3x squared. Negative 7x divided by -1 is positive 7x. Positive 9 divided by -1 is -9. And so our polynomial becomes -1 times 3x squared plus 7x minus 9.